All right, shall we go to question number 2? Okay, question number 2 is about momentum, because I already see the word momentum here already. So we have a space vehicle here drawn for you. Space vehicle moving at 0.5 meter per second, about to dock with the space probe moving in the opposite direction. You know what's dock or not? Dock basically means parking. Okay, parking, right? Like, oh, dock the ship means you park the ship. Okay, like parking the car like that. So he wants to park on top of this thing, basically like that, connect together. Yeah. The mass of the space vehicle and space probe are 2,500 kg and 1,500 kg respectively. Okay, so space vehicle is this guy. This is 2,500 kg. Okay, and then space probe is the other one. That's 1,500 kg. Okay, after the docking procedure, the space vehicle and space probe move together at 0.2 meters per second in the original direction of the space vehicle as shown in diagram 4.2. This is after they connect together. They both move at 0.2 to the right. What is the collision that occurs in diagram 4.2? Now we have 3 types of collision. We have elastic. Elastic meaning like it's bouncy. Okay? When you have 2 things bang together, if you can make the sound effect toing, toing, toing like that, that means it's elastic already. Okay? So whenever you hit and then you separate, it's elastic. If you hit and you don't separate, if you hit and you stay together, that is inelastic. That is what's going on here lah. Okay, they hit and then they stick together. This is inelastic collision. Okay, now one more type of collision is called explosion. It happens when 2 things are originally together and then suddenly, boom, they separate. Okay, that's explosion. Okay, now, based on the information provided, calculate the total momentum of the system. Okay, let me tell you something. In your formula sheet, right, you don't get any special formula for momentum one, you know. You don't get whatever M1, U1, V1, U2, M3, V3, V4, father, whatever, don't have. There's only one formula for momentum, which is mass times velocity. That's the formula for, you know, momentum. So don't expect they will give you like any special formula like what is total momentum. No, you have to understand yourself. The meaning of total momentum means your momentum plus your momentum plus your momentum plus your momentum. That's total momentum. Okay? So you want to get the momentum of these 2 people, you have to add their momentum together. So the total momentum, you just add the first person's momentum, which is mass times velocity, plus the second person's momentum, mass times velocity. Okay? This one is for the space vehicle, this one is for the space probe. All right? Now, if you look at it, right, you got the mass of the space vehicle, that's 2,500. You have the velocity of the space vehicle at 0.5. You got the mass of the space probe at 1,005, but you don't have the speed of the space probe. Right or not? So what then? So what now if you cannot find the V? Because you don't have this, you cannot find total momentum. But never mind. You just have to look at this. Look at the after. Look at the second diagram. You see, the mass of this space vehicle is the same, 2,500. The velocity of this space vehicle is this, 0.2, plus the mass of this space probe is 1,500. And then the velocity of this space, bro, is also 0.2. Because they move together, ma. Right? They move together, so their velocity must be the same one. So this is 0.2. Okay? So can you calculate what is the total momentum for me? Okay, I have one 800 here. I have an 800. Anyone else confirm this answer? 800? Okay. All right, thank you. Now, here's a real question. What's the units for momentum? This is a real question. What's the unit for momentum? Any ideas? Anna? No. Okay, all right. 10. So it is kg ms negative 1. Okay, all right, later I explain that. All right, kg comes from mass and meter per second comes from velocity. I'm just combining these two people's units together only. Okay, is that ns? Actually, it is. Actually, it is Newton second because Newton is kg ms negative 2. All right, yeah, so it is Newton second, but we normally use this instead lah, right? We rarely will use ns1. Okay. All right, now someone asked, teacher, I thought need to convert kg to gram first. Actually, no, because our SI unit for mass is kg. Gram, you have to change to kg. Okay, if it's 800 gram, you have to change to 0.8 kg. Yeah, so our SI unit is kilograms for mass. Okay, time will be seconds, distance will be meters. Yeah, now, what is the speed of the space probe before docking with the space vehicle? So the speed of this guy before docking is this, the thing that I was missing just now, correct or not? Just now, I didn't have this thing, right? If I write back down the same thing, if I write back the same thing, just now, I didn't have this. Sorry, not MU, MV. Okay, I didn't have this. But what's the difference now? Now I have this already. I know this total momentum is 800 already. So if I use back just now what I wanted to do just now, 2,500 times 0.5, and then plus 1,500 times unknown. Okay, so now you can get what is the initial speed already, because now I already know the total momentum. Okay, you give me the V, and don't worry if it's a negative number, you are supposed to get a negative number because originally this guy was moving in the opposite direction. You are supposed to get a negative velocity one. Is it negative 0.3? Is it negative 0.3? Oh no. Oh, getting some bad feelings here. Why nobody dare to confirm your answer? Okay, negative 0.3 confirm. All right. Negative 0.3 meters per second. Okay? Negative 0.3 meters per second. Yeah? So actually, when you do the calculation, you need to be very, very sure that the directions you got checked. Okay? If let's say I was supposed to do this first, then I must put a negative here. Whatever this number is, I supposed to put a negative here. If let's say I were to do this thing first, because opposite direction, velocity got direction one. Okay? Now, what gave me the who gave me permission to take this 800 and make it same as this? Because when I did this one, right, I was using the after collide. But when I do this one, I'm doing the before collide. So who gave me the permission to make the total momentum same? So there's this thing called the principle. What's the word? Principle of what? Principle of what? Yes, very good. Conservation. Okay? Conservation means must be the same, must always remain the same. Conserve what? What are we talking about? What is the same? The momentum same, no? So principle of conservation of momentum. Okay? Conservation of energy is another principle, but it's also a real principle. It's also real. But it's just not for this topic. This one we're talking about momentum only. Okay, so what does this principle say, right? You can say the total momentum before collision and the total momentum after collision must be the same, must be equal. Okay? Total momentum before collision and after collision must be equal or must remain the same. Hey, do you remember how to explain how a rocket works or not? How many times I taught you this already? Yeah? How many times I asked you to copy that paragraph? The paragraph that will always get you full marks one. All you got to do is change the object and you're going to change the direction only. Yeah, remember that? Okay, so first of all, you tell me first, what does a rocket shoot out? What does a rocket shoot out? Yeah, the rocket don't shoot out fire. You don't say the rocket shoots out fire. The rocket shoots out hot gas, correct? Okay, so this hot gas, right? It's up to you. The first one is optional. It's up to you whether you want to tell them where does the hot gas come from or not. Okay? You could always add a sentence in front one and say, oh, the hot gas is because there's combustion. Yeah, but that's totally optional because other questions you don't have to explain them. For example, if you shoot a bullet, you want to explain why the gun fly back. Do you need to explain where does the bullet, why does the bullet move? No need If let's say I want to talk about the squid shoot the ink. Do you need to explain how the squid produce the ink? No need so this is optional one. So if you want, you can add and say combustion in the rocket produces hot gas. Okay? Now, for the key part. Okay, everything after this, I told you already, it's all usable for any question one. You just gotta change the few words only. So first of all, you say, this hot gas needs to go where? This hot gas needs to go down. So hot gas moves downwards. But that's not enough. You can't just say the hot gas move downwards. You must say the hot gas move downwards at high velocity. Why is that? Why do I need to say that the hot gas moves very quickly? Why cannot move slowly leh? Why must move with high velocity leh? So that I can do what? So that I can produce what? Why the hot gas must move at high velocity? Yes, correct. It's so that you can produce a very, very high momentum. This produces a large downward momentum. Okay? This produces a large downwards momentum. Okay, then according to POCOM, this POCOM not for you to buy golden, this is Principle of Conservation of Momentum, POCOM, POCOM. According to POCOM, there must be an equal but opposite reaction. Okay, so basically the principle of conservation of momentum. Oh, cannot write in exam, cannot write POCOM. No. In exam must write the full word. Must write the full word. Okay, so basically according to this principle of conservation of momentum, right? If something go up, something must go down. If something go left, something must go right. If something go forward, something must go backwards. That is the law. Okay? So there must be equal but opposite. You can even say what? Equal but opposite upwards momentum if you want. Okay, because you already know that one was downwards, so the equal but opposite is upwards momentum. So therefore, the rocket moves upwards. Okay, the rocket got no choice but to go up. Okay? Yeah, so I can use this for anything. Let's say I want to explain why when I fire a gun, the gun will always move backwards. Because the bullet moves forwards at high velocity. This produces a large forwards momentum. According to principle of conservation of momentum, there must be an equal but opposite backwards momentum. Therefore, the gun moves backwards. Okay, any example for momentum explanation you can use. Always will get 4 marks. Ngam. Okay, understand? Anyone still copying this? Anyone still copying? Okay, done. All right, let's go on to the next portion. You write this, you get full marks every time, correct? Of course, you must write the correct thing lah. You don't the thing ask for rocket, then you talk about jet engine, then wrong lah. You must write the correct object and you must write the correct direction. But you follow this exactly right, no problem one. Okay, you follow this format, you will surely get full marks. Okay, all right, now, next one. The diagram below shows a water rocket made by a student. So water rocket is similar to rocket, but doesn't shoot water lah. Okay? And you need to modify the water rocket lah based on this, whatever, all these different things lah, okay? And then you want it to travel the maximum horizontal distance. Okay? Horizontal distance, All right, now first one, material. Can you tell me what kind of material do I want for my rocket? What kind of material do I want? Again, no name of material. I don't want the name. I want the characteristics. I want the type. What kind of material? Solid. Glass also solid, ma. Right. Solid not good enough. Another word. Okay, light material. Let's say I don't want to write light material. Let's say I want light to be my reason. So like, what kind of material should I use so that the reason is it is light? What kind of material should I use so that the reason is it is light? Also, just now who worried about essay one? Now is your chance already. Come on. What kind of material should I use? No. I don't want the name of the material. I don't want the name of the material. Again, let's say I don't want to say light material. I don't want to say light material. Instead, I want something material. Okay, yeah. So that the reason is, I choose it because it is light. Yeah, I want that to be my reason. So it should be low watt. A material that is low watt, so that it is light. You see this word a lot one in essay question. You see this word a lot one. Yes, very good. Low density, correct. Low density material. Okay, besides low density material, if I don't want it to break so easily, I don't want it to break so easily because when you spray the water, it's very, very strong one. So I need the material to be not solid, but strong, correct. Not hard, I want this to be strong. Hard and strong is two different things, okay? So either you say strong material or you say low density material. Okay, so if you put strong, doesn't low density make it not strong? No, because low density, right, actually just means mass and volume. Okay, density is mass and volume. So the strength of the material doesn't depend on these two things. Strength of material doesn't depend on these two things. Because we have something like carbon fiber. Carbon fiber is super strong, but it's super light. So it's low density. But then it's very strong also. So strong material, you can say it's durable. You can say it does not break easily. Okay, and as for low density material, you can say because it is lightweight. Okay, you can say can fly higher. You can say greater acceleration. Anything that's logical. Anything that's logical. If you're wondering, teacher, can I write like that or not? You can ask now. Okay, then I can let you know whether it's suitable or not. Okay, number 2, the shape of the rocket. I want my rocket to look like what shape? There's a very specific word that I'm looking for. There's a very specific word that I'm looking for. This kind of shape makes it go faster, fly higher. What is that shape? Not cone, not pencil, but you know what I'm talking about. Front sharp, like that. Okay, correct. For the rest of you, do you still want to try to guess? Starts with the word arrow. The bullet train is also this word. Bullet train shape is also this word. Arrow something. Arrow. Like that. Aerodynamic. Okay? Yeah? I want you to put this word inside your head. Yeah, just add this word into your dictionary because you're gonna use this word so many times. Okay, in physics. It's a wrong arrow, correct. Yeah. But let me tell you, you are not the only person that wrote arrowhead. Yeah. You are not the only person that wrote arrowhead. Let me tell you. There are other people that wrote arrowhead as well. Okay? So yeah. So I wouldn't say you are completely wrong because other people thought of the same thing also. Okay, so yeah, this word you must remember because like jet plane or like bullet train or like sports car, they are all this shape so that the air can just fly past. Okay, the air can fly past. So aerodynamic shape is to reduce air resistance. Where's my aircon remote? Oh, aerodynamic shape to reduce air resistance. Sun is so bright outside, no wonder it's so hot. Just now some more raining. Wow. Yeah, for people in the Klang Valley, you all know, just now it was raining, sky was very dark, then suddenly the sun just came up. Okay, third one, angle of launching. Now, angle of launching depends on where you want it to go. If you want it to go up high, the highest height, of course, you got to launch it straight up lah. You got to shoot it straight up. But right now, I want it to go the maximum horizontal distance. So how should I launch the rocket? If I want it to go the maximum horizontal distance, do I launch it like this, lying on the ground? Do I launch it horizontally like this? Since if you want it to go maximum height, then you should launch up. Then if I want maximum horizontal distance, then should I launch it like that? What's wrong with launching it like that? Why I cannot launch like horizontally to get the maximum horizontal distance? Exactly. The ground slows it down. Yeah. The ground will have some friction. It will basically tumble along the ground and then it'll just stop very quickly. Okay. So if you shoot it upright, at least you will have some time to travel and then fall down. Okay. Now, going straight up will go up and then come down. If you go sing it a little bit, it'll go up like that and then come down here. If you go too horizontal, then it also drop down very quickly. So 45 degrees is the way to go because it's a perfect balance of up and horizontal. Up is so that he doesn't land on the ground so quickly. Horizontal is so that he can basically travel horizontally. Okay? Yeah. So 45 degrees is the perfect balance of height and distance. Okay? So you can say launch at 45 degrees. Okay? Launch at 45 degrees angle. You can say the rocket can travel maximum horizontal distance. Okay? The rocket can travel maximum horizontal distance. Okay, next one. volume of water in the rocket. How much water should I put in the rocket? How much of the bottle should I fill up with water? How much? Try to guess. Any of you actually did the water rocket in school or not? Any of you actually got make the water rocket in school? No ah. Alright, so sad lah. I remember got one school got do water rocket before, but I'm not sure which school got. I forgot which one already. So how much water should I put in? Whole bottle? Full bottle? 3/4? 3/4? Why not full bottle? Why not full bottle? If you're gonna put 3/4 anyway, why not just put the whole bottle water? Not pressure. Okay, yes, it's too heavy, correct. If I fill the whole bottle with water, it's gonna be too heavy for it to fly. Then why not just put like 1/4? Why not just put like 1/4 of water? Just add any, just a little bit. Why too less? Not because unstable. It's not unstable. But why is it too little? Why too little water cannot work? Very good. Not enough momentum. You remember, the rocket needs to shoot hot gas. So the water rocket needs to shoot water. If you don't shoot water down, you cannot fly up. If you don't have enough water to throw away, you cannot fly up also. So you need enough water to throw out. But you cannot have too much water also, otherwise you'll be too heavy. So if you write 1/3 can, half also can, but only around like that only. Okay, either 1/3 or half only. Yeah? 1/3 of total volume or half. Okay, so that the rocket can produce large momentum without being too heavy. Okay, the rocket can produce a large downwards momentum because you can shoot the water out, but you are not too heavy. Okay, and the last one, what can I add to the water? Add to the water, blood. No, you don't add anything to the water. That one is cheating. What can I add to the bottle, to the rocket? What are these things called? What are these things called? Add a jet engine to the rocket. Can. Of course can. If you add jet engine to your water rocket, I'm pretty sure you will be the winner lah. And then I think your school will give you scholarship also lah. If you can make your own jet engine at home, I'm pretty sure they'll give you a scholarship also. Okay, what are these things called? These things. Like the fish, they have this thing also. Correct. These are the fins. Okay, these are fins. Add fins to the rocket. You know what the fins are for? Do you know what the fins are for? Like, what are the fins on the fish for? Do you know? They're actually the same purpose, you know? It's the same purpose one. Why the fish need to have fins and why the rocket need to have fins also. So what? Two? No. The fins add air resistance actually. Anything extra you add is extra air resistance. So it's not lower air resistance. Actually, it's to keep the rocket stable during flight. Okay? Hello? Fishes don't use their fins to breathe. Fish use their gills to breathe. The fin is that one and the one behind up there. Like the shark fin, that one is fin. Okay, is to keep it stable. You try to take a water bottle and you try to throw straight up. It will never maintain like that one. It will always try to bloop, fall down like that one. You throw up, it will fall down like that. You throw up, it will fall down like that. Okay? So they need the fin to actually make sure they are always like straight like that. So fish also. If the fish they got no fins the fish will like whoop, flip over one. Okay, they cannot actually swim properly one. So the fins is to make sure they always maintain straight like that. Yeah.